Homeostasis is fundamentally just the body's effort to control its internal conditions and its ability to keep a certain variable at a consistent value. For example, um, if we have body temperature, right, where your normal body temperature is supposed to be at 98.6 degrees Fahrenheit, then what the body will do is, in response to fluctuations to the outside temperature, it will still make sure that the internal temperature is at this 98.6 degrees. And so what it will look like, right, is that maybe uh, it gets super hot outside. And so your body temperature begins to raise, and then the body will be able to keep that temperature raising too much and balance it out. And then as to balance it out, perhaps it overshoots a little bit and corrects itself, and outside gets a little bit hotter. Um, the body will go back, and this process just keeps going, where the body is trying to maintain a variable at what's called set point. And this happens everywhere in the body. It happens with blood pressure, blood pH, blood glucose levels, uh, oxygen levels. And it's really just homeostasis is the body's attempt to keep the body stable and consistent no matter what changes are happening outside. Now, the way it does this is through what's called a reflex control pathway. And right here is the outline of what that looks like. And it's how the body controls its internal organs and things. So what happens is you'll have a stimulus. And in the context of body temperature, perhaps the stimulus here is heat, right? The body increases in heat or it gets hotter outside. And what happens is receptors in our skin understand that heat um, and then send a signal to the control center, which would be our brain. And that pathway between the receptors and the control center is called an afferent pathway. Then once it gets to the brain is where, or the control center is where the set point is stored. And so if this stimulus is different than the set point, then the control center will say, hey, we need to change that. And it will send an efferent signal to the effector organ. Now that can be a variety of different things. Typically, the afferent and efferent pathways are either the blood or nerves. Now, this reflex control pathway, these pathways, they can have a variety of different effects. And oftentimes, the effector will come around and impact the stimulus. And that's where we get into negative and positive feedback loops. Um, and a negative feedback loop is primarily where the body is attempting and doing its best to keep the variable at a set point. And so, for example, with body temperature, if we go back up here, this is what we would call a negative feedback loop, because in responses to changes, the body is doing its best to keep the value at a set point. And so, in response to the stimulus of heat, then the control center will tell effector organs to vasodilate or sweat, right? If it gets too hot, the body will tell itself to sweat, which will then decrease the heat that occurs. And so the goal of the body is to get it so that the stimulus no longer really exists. And so as the effector organ, as we continue to sweat, that cools down the skin and decreases the stimulus of heat. And that would be called negative feedback. Another example would be blood pressure, where if if for some reason you decrease in blood volume, maybe you didn't drink enough water in a certain day, your blood pressure may start to decrease as well. And the body needs to keep the blood pressure in a specific range. And so that stimulus gets perhaps some sensors in your blood vessels. They receive the stimulus um, of blood pressure. They see that the blood pressure is going down. And so they send a signal to the brain. The brain then sends a signal back to the blood vessels, and they can so constrict, which will increase peripheral resistance, leading to an increase in blood pressure. Um, and we can assume the set point is like right around here. And so it'll be an increase in blood pressure, and then there'll be a stimulus that says, well, that's too high. It goes back to the brain. The control center does the brain sends an afferent nerve signal back to the effector organs, the blood vessels, and tells it to release a little bit, meant to decrease the peripheral resistance. And so it would go back down. And this process just keeps happening over and over again as its body's effort to maintain a variable at a certain set point, to always move the variable back to set point when there's a deviation. Now, this can be inadequate at some points. The body temperature, um, for example, if it gets way too hot on a given day, then it could look like the temperature's going up and the body's trying to bring it down. It just keeps going up and because it's too hot. Um, that would be an inadequate negative feedback loop because the body is still working, right? The stimulus is going to the receptor, the receptor signal, sending the signal to the control center sending the signal to the effector, and the effector is working. You are sweating. But if it's too hot, then it's inadequate. Now, that's negative feedback. Positive feedback uh, is the opposite, where the body is trying to move the variable away from set points. Or maybe the body's not trying to do that. It could be intentional or unintentional. Now, we can consider, for example, um, in the context of birth, this is actually an intentional positive feedback loop where, sorry, let me use this up here. In birth, what we have is we have a stimulus where the body or the baby, sorry, is pushing on the cervix, and that produces stimulus. The receptors on the cervix uh, receive that stimulus of the baby pushing, and they send an afferent nerve signal to the brain, and the brain then sends an efferent signal in the blood through oxytocin and tells the uterus to contract. Now, this contraction, instead of decreasing the stimulus, what it does is it actually increases the stimulus because that forces the baby to push more on the cervix. And that further increases the nerve signals that are sent by the receptor to the control center. The control center sends more nerve signals to the effector. Oxytocin goes further, the uterus contracts more. And that results in a positive feedback loop because that goes back and causes the baby to push more on the cervix. And that would be a positive feedback loop because the variable, the baby pushing, doesn't stop putting pressure on the cervix. It keeps increasing and increasing, moving further away from set point. Now, this could also happen unintentionally with blood pressure, where you have the set point, and say this time instead of just a water deficiency which your body can handle, say it's you got your leg chopped off, right? And so what happens is blood volume decreases And with that, so does blood pressure. Now, your body tries to fix this. And so what happens is it increases the heart rate. Because as heart rate increases, blood pressure should increase. However, as the body seeks to respond to this new stimulus, right, of, of blood volume going down, and the veins and the arteries can can receive this information. It goes to the brain and it tells the heart, which is then the effector organ, to increase its rate. Now, this will increase blood pressure, but at the same time, this will cause more blood to flow out of the limb that you've gotten cut off because more blood will leave. And so the heart here actually increases the stimulus of blood volume, where the blood volume continues to go further down. Um, and that then also causes the blood pressure to go further down. And so what happens, and then eventually, right, the blood doesn't get, there's not enough blood to get to the heart, and the heart will stop pumping, and then blood pressure will be forgotten. There's no way that you could continue to increase the blood pressure. And so what would happen is instead of going in a nice kind of wave like this, the blood pressure has completely tanked. Um, and sorry, I should probably start around here. So say it was at set point before, it goes down and it just keeps going down and down further. And now this was an example of another positive feedback loop, and it was unintentional, but it was caused because something was broken. Um, where your skin, right, the thing that holds the blood in, no longer worked the way that it should.